So children, today we will discuss potential energy. Potential energy. Okay. First of all, what is energy? Energy is called capacity to do work. What is energy, children? Capacity to do work. There are different types of energy, children. Potential energy, kinetic energy, muscular energy, light energy, okay, sound energy. All these are different forms of energy. Heat energy. Among that, for our ninth and 8th class, potential energy is very important. What is potential energy? Potential energy definition. In exam, if it comes, you have to write like this. Energy possessed by a body by energy possessed by a body by virtue of its position. Virtue of its position is called potential energy. Position. What is position means? What is position means, children? Position means it is a certain height. It is certain height. It is certain height, or it may be some position. If ever any body has position, then that body is said to be having potential energy. That body is said to be having potential energy. Okay, potential energy, like example. See now, see here, children, all of you. If I catch this pen like this, it is certain height. At certain height, this pen is having potential energy. If I release it, it will fall down. If I release it, it will fall down. Okay, children, stone is there at certain height. Okay, it will be fully filled with potential energy. If I release it, it will fall down, and during the course of its falling, all the potential energy changes into kinetic energy and falls with kinetic energy. On reaching the ground, potential energy will become zero because no height, no. If there is no height or no position, potential energy is said to be zero. Children, we know work is equal to force into displacement. Force from Newton's second law, we know mg, and s, because it is falling from certain height, h, and all the work done is converted into potential energy, and the potential energy formula is mgh. Units are same, children, whether work or potential energy, units are same. Joules in SI system and ergs in CGS system. And also I told 1 joule is equal to 10 to the power of 7 ergs. Derivation also I told. And the dimensional formula is ml square t minus 2. Energy and work are different. Same, children. Okay. So any body which is at certain height compulsory will have potential energy. Now we will discuss some more examples of bodies having potential energy. I'll discuss some more examples. First, you should understand a position is there means the body will have certain potential energy. Okay, I hope you are able to understand, children. See here. So, potential energy formula is mgh. Units are joules or ergs, and 1 joule is equal to 10 to the power of 7 ergs, and ml square t minus 2. And the definition is by virtue of its energy possessed by the virtue of its position. By the virtue of its position. Examples. Some best examples I will give, children. Listen. Very, very important. Any body at certain height, will have potential energy. Example, suppose, children, this is your dam. Okay. In the dams, water will be stored at great height. Why? Because at great heights, so potential energy will be very, very, very high. At great heights, potential energy will be very high. When they open the gates, from this much height, water is falling down, means all the potential energy gets converted into kinetic energy, and they flow with very, very, very high velocities. They flow with very, very high velocities. Okay, so when they flow with high velocities, what happens means when they flow with high velocities, what happens if you keep in their position any turbine, their turbines will rotate. When turbines are rotating, this movement of water, turbines keeps rotating. When turbines are rotating, they are connected to generators produce electricity. Okay, whether you understood this concept or not, leave it, but remember, any body which is at great height will have great potential energy. Number one example. Apart from this, one more example I will give, children. You all know bow and arrow. Okay, you all know bow and arrow. Okay, So children, arrow here you will keep. After keeping here arrow, what you will do children? You will stretch. You will stretch it as no. You will stretch. A stretched bow and arrow. A stretched arrow will have a lot of potential energy. A stretched arrow will have full potential energy. When you release it, all this potential energy gets converted to kinetic energy and it starts moving very, very, very fast. In tomorrow class, I will say kinetic energy, children. Any body moving will have kinetic energy. Any body at certain position will have potential energy. When you stretch it, it will have potential energy. When you release it, all the potential energy changes to kinetic energy and it goes very, 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 very fast. A stretched string of bow and arrow will have what energy, children? Potential energy. A stretched one only. Once you release, over. Potential energy starts converting into kinetic energy. One more example for your clear understanding, children. See, children, this is your spring. Okay, this is your spring. Okay, if you coil the spring in toy cars, will be having no children. We will coil the spring. We will with key. We will keep on coiling it, and we twist it, and we'll coil, and we'll make the spring full tight, and we'll release it. What happens when you release? Toy car starts moving. Why toy car starts moving? The coiled spring starts uncoiling slowly. It uncoils means when it is tightly coiled, it will have potential energy. When it is released, all the potential energy gets converted into kinetic energy and our toy car starts moving. So three examples I gave, children. One is water stored in the dam. Anything if you hold a stone, if I hold the pen, it is also having. If you jump up, okay, if you are there on the building, imagine if you are there on building, okay, you also have potential energy. If you jump down, potential energy converts into kinetic energy. A structured tightly coiled bow and arrow string also have potential energy. Tightly coiled spring also have potential energy. All these things when released gets converted into kinetic energy. These are some of the best examples of potential energy. And onwards, nowadays they are asking one question: a bird moving in the sky, will have what energy? Anyone? A bird moving in the sky will have what energy?
Potential only, sir.
A bird moving in the sky will have what energy?
Kinetic energy.
Bird
Potential
moving.
energy.
Listen, children, please don't shout, Nana. A bird moving in the sky will have both potential and kinetic energy. Why means it is having height and it is also moving. If it is stand there only, then potential energy. But it is moving also, no? So that's why potential energy and kinetic energy. An aeroplane in the sky will have what energy? Same potential and kinetic energy. You are able to understand, children. If it is having position, it is potential energy. And if ever it is moving, it is kinetic energy. These are some of the famous examples of potential energy. Anything at height, a tightly structured string, a tightly coiled spring are some of the best examples of potential energy. Okay, so potential energy definition: any energy possessed by virtue of its position. Formula: mgh, where g is acceleration due to gravity 9.8 and h is the height. Okay, and units of joules are earths. 1 joule is equal to 10 to the power 7 earths. Dimensional formula: ml square t minus 2. Potential energy or any energy is definition is capacity to do work is called energy. What is the definition of energy? Capacity to do work. Work and energy are same, synonymous. Capacity to do work is called energy. Okay, children. 2-3 numericals I will say. All of you listen. Then I will give 2-3 numericals for you to practice, children. Okay. Please check. First question. Don't shout, children. Find potential energy of body 2 kg, which is at height of 10 meters. That's all. What is the formula of potential energy, children? mgh. 2 into g is how much? 9.8 into 10. 9.8 into 10, 98. 98 to the 196 joules. That's all. Over. Means a body 2 kg body at 10 meters will have how much energy? 196 joules of energy will be there. That much energy, when it falls on the ground, it will give that 196 joules of energy to the ground. That much energy or that much work. Okay, children. One more question. Those who didn't understand. One more question. Find potential energy of a body which is 200 grams at height of 100 meters. Okay, children. Same formula. M is how much? 200 by 1000. G is 9.8. H is 100. Okay, children. Two zeros, two zeros. 10, 10. 9.8 into 10 is 98. 98 to the 196 joules. Again 196 joules. So potential energy of that body is 196 joules. Okay, children. I will send the video, children. In the video, link will be there. Description link will be there. Homework will be there. Please do that homework. Okay. In the description, link will be there. Press that link. Homework will open. Please do that homework. All the sums and questions will be there. This is potential energy topic. Okay. Anyone have any doubts? You please ask me now.